Alrighty, what have we got today? We've got a fan. Sure need one. It's pretty hot at the moment. It's what are we, 11 in the morning, and it's about 26 degrees inside already. Horribly humid. This thing makes it even more humid. Actually, it'll spray a mist of water out from the center, so it feels cool, but it certainly adds to the humidity. But this one, there's a problem with the fan. It's not spinning. It spins very slowly. It takes a long time to get up to speed, so it's low on power. I'll show you what I mean. So with it on, you can hear the motor humming, and it barely turns. We'll crank up the power. So that's at full power. Nah, doesn't want to go. Was going before, but just sits there and hums. Is it the motor? Is it dry bearings? Is it the MOSFETs that feed it? Or triac probably. Let's find out. Let's remove the grill. So it's held on by a ring around the outside. There's no clips on this one. The bigger ones have clips. So we've got to undo that ring there. So with the ring loosened, looks like the front section will come off. We'll want to take this pipe off, I guess. That feeds the moisture up to the outlet. There we go. Just pulls off. Now, does this feel like it's spinning freely? It really does. I don't think there's an issue with bearings. Perhaps we pop the back off the motor. Unplug it from the wall for safety, of course. Now these all look like Phillips screws. We've got 3 there and a couple at the bottom. Well, I thought there might be some discoloration in the windings, but it's just sort of shadowing the way the light falls behind the metal and that. Everything looks pretty clean in here. So I think we'll need to unhook the wirings to get the end of it and maybe do a couple of measurements. Maybe there is an open in one of the windings. So unstrap that and see if we can figure out how it all comes apart. There's a zip tie around there, probably have to take off. Alright, and it's all sort of tied in around the windings as well. What have we got here? A couple of leads into, okay, so the 2 white wires go down to this motor which does the oscillation, and they are teed off, so this will be phasor neutral here. It could be fed straight up from the bottom. I think this comes up from the bottom and then this just goes to a shared neutral. We do have, oh there we go, there's a capacitor over there, so I guess there's a chance that this is bad. If that is bad, then we're not going to get our offset to create torque and the magnetic fields. So possibly a good thing to check first. Still bundled up though. So I think instead of untying all this loom here, it's going to be horrible to tie back up out the way of the rotor. I'm just going to leave it, and what I'll do is we'll come back down and we'll pull the back cover off and we'll measure it from that end. So that would be a lot easier, I think, and safer. Of course that doesn't say if there's a break in the wire if it'll help any, knowing that this is getting full voltage, but I guess we can at least check the other end. Probably do some resistance readings and give it a wiggle if we're unsure that there actually does come all the way up and not break down here where it's pivoted a lot, but that's a possibility, I suppose. But I would think it's switching in different windings for different speeds, perhaps not so much different voltage, but we'll find out. I don't know. So we'll get the back cover off, and it is A whole bunch of screws down each side. Yeah, actually I think the front falls off these ones, not so much the back coming off. Should just pop off, unless I've missed one. I bet they've hidden one behind the water bucket there. Got to remove the drain plug at the bottom corner there, and it wasn't recording any of that. So with the base off, it does hold the two halves together by wrapping around the edges. So once that's off, the whole lot comes out with the water tank assembly attached to the front as well. Well, they're all falling apart. It's much easier to get it up at bench height. So get rid of the spiders. Here's our cable off to the fan. We've got our yellow wire, which is our fan oscillation motor. We've got two other wires, or three other wires. So one's going to be in neutral, and then the other two, oh no, the other three. So we've got low, medium and high. And then if you have a look, there's actually a black wire snaking up the side there, so that's going to be our neutral. Comes over to here to N out, neutral out, and neutral in, which comes off to our mains input. So we've got our black wire going up to the fan there, and neutral out from here, neutral in on this side coming from the mains connector. So neutral, it's a shared neutral, that's what the other yellow wire tees into up top. So that's our oscillator, and then we've got our low, medium and high. So I guess we want to have a look at the voltage present, what's going on during the low, medium and high setting, and then we can decide whether if we have a drive issue or an issue at the motor end. So we're in AC on the multimeter. I'll just turn it on, and that should be low by default. So if we go from our neutral out down the bottom there, 237, get a better connection, 214 on mid, and 170 on high, and then on medium we've got 240 on low, 237 on medium, and 190 on high, and then on high we've got 240, 240 and 240. You can see it's switching variously through each of the outputs, so that should be enough for the motor to work. So we probably have an issue at the motor end. Might just flip the board out and just have a look on the other side too. 4 screws, and just to make sure there's nothing funny going on over here. So we've got these transistors up here that are switching in the main supply. We have series resistors on each one, looks like 470 ohms. I mean, we could measure those, make sure they're okay. They are SCRs as marked on the board, so we've got SCRs operating all of those. As we saw though, that they were each being switched up a notch in turn, and on high it did have 240 on every single one. So it's looking like that there's really no issue there. I wonder if we can get a resistance reading between neutral and each of those windings. So if we go to neutral and low, so we're at 1k, neutral to medium, a little bit less, neutral to high, a little bit less again, and if we go between the windings, so low to medium 114, low to high 353, medium to high 228. I don't know what it should be, but I guess that's normal. It's not ridiculously low and it's not ridiculously high, and it's incrementally more, so I'm going to say that's probably fine. And then if we check these 470 ohm resistors in case you're interested, so they are 470, 470, 470, they're all good, they're all good. So as far as we can tell, it's getting full voltage up to the fan head, and maybe looking more like that capacitor anyway. So I think we'll try and obtain one of those caps and pop it in, and we'll just see if that has an effect on it. So I've got one, it's not perfect, it's 1 microfarad, whereas this one's 1.5. This one's also rated at 450 volts, so plenty of room for error, and this one's only rated at 250, which is below the mains around here, but not a lot of headspace, but it will be a good test, I suppose. So I think what I'll do is we'll just chuck it on, we'll see what happens. 2 lower capacitance will not give us enough starting torque, which is what we're kind of experiencing if this has failed and gone low. 2 higher capacitance will give plenty of torque, but it'll draw a lot of current while running and things will get hotter than it should. So I'm going to cut that off, and we'll measure that, we'll test that and just see out of curiosity. As we can see, if we test our new one, we're about 1 microfarad, a little bit under. If we test our old one, so it's 139 nanofarads, so that has dropped considerably. So I think we're on the right track. So this is why we keep junk. We've got one here. It's 275 volts and looks like 1 microfarad. So that would be better leeway as far as the voltage goes. So I'm going to pop that off this board and we'll measure it, and if it looks okay, we'll stick some wires on the end of it. Got it off the board. This is an X2 class rated capacitor, so that would be suitable for what we're doing, and we will see how good it is. 0.8, supposed to be 1 microfarad, so it's a little bit down. It's actually half a microfarad less anyway on what we originally had. It just means that its starting torque is going to be a bit down, but it should be enough to get this thing spinning. So as a test, I've just soldered it on there. If this works, I will add heat shrink to the ends. Although they're pretty well spaced apart, it's not really going to be an issue in there, but you know, we will. And yeah, let's see if it spins up. If you're ever uncertain about what you're doing, just pop a blast shield on it. Alright, turn it on. Right, we'll turn it on, and it should be low speed to start with. Remove anything loose from the bench that's going to blow all over the place. Here we go. Oh, it's taking off a lot better. Excellent. Okay, let's go to medium. Yeah, that's definitely ramping up. And now we'll go to high. Yeah. That is more than adequate. Excellent. It's what I thought it was from the start, but you know, why not look at things and make absolutely sure, and you guys get to see what's inside the fan controller. Cool. So that said, let's put some heat shrink over that, tidy it all up, and get it together and make sure the rest of it works. Bit of heat shrink. Keep it away from the terminals while you're soldering the wire back on so it doesn't shrink from the heat of the soldering. Now of course we're going to heat shrink this because there is a lot of water vapor flying around in the air, as you'll see shortly in the demonstration. So this will just help keep any humidity from forming between the two, or if everything becomes wet, you don't want the fan grill to become charged. Solder irons are generally usually hot enough to do it. It's a bit slower this way, but it does work fine. Now we'll wrap a new zip tie around that bundle. And of course tuck that back over there where it used to live. I'm wondering if there's moulding on here. Ah, yes, cool. So there is a piece here that will sit down on the capacitor and hold it in place, so we don't need to glue it or anything. That should stop it popping out. There we go. So this one appears to use I guess a high-powered version of those fogger circuits that create a water mist, and similar to those aromatherapy type diffusers. But yeah, just down in here, that's the piezoelectric device that oscillates at a high frequency and atomizes the water into a fine mist. So I'm picking it's a lot more powerful than your average diffuser, but you can see the staining from the water line maintains a level with the other half of the tank that just sits over the top. There's no water seal around it. It just obviously it'll empty out to reach a certain level and steady itself and automatically feed through. There's the driver board. Not a lot going on here, but of course should the seal in the piezo device fail, it'll flood through here and naturally destroy it. But these things we don't worry about until they happen. Well, she's all back together, but what I do want to do is fill her up, make sure it doesn't leak out everywhere before we plug it in, just because there is electronics on the bottom there. So let's just make sure that that is okay. I can hear it emptying into the bottom, and if we're lucky that'll stop. And that's come to a stop, and hopefully we won't get any leaks. I'll let it sit there for a couple of minutes to make sure. So my camera is not waterproof, so I'm going to show you from side on how these things work. If I go in front of it, it's going to get absolutely drenched. So let's fire it up. We're on low. You can see it ramping up quite nicely. So I put it onto medium, and now I'll turn on the misting action. Hopefully that's showing up on camera there, but there is a fog coming out of the front of that. Let's see if there's an extra high power mode for mist. There we go, that's ramped up. That's a bit more obvious, isn't it? Maybe if I shut the door and make it a bit darker, it might stand out. Or maybe not. Anyway, I guess it's a bit hard to get a bit of an angle on it. I guess it's not putting out as much as I thought it might. I'll probably get in front of it a tad. There we go. It's not so wet. not like the bigger ones. There's a couple of sizes you can get. This is a small one. The bigger ones absolutely drown stuff that's in front of it immediately, but yeah, pretty neat. And yeah, that does with that water vapor does make it feel a bit cooler. You can also put an ice pack in there. That's that blue bottle over on the wall, and if you freeze that and chuck it in, it keeps the water nice and chill, which has the added benefit of chilling the mist as well. So I hope that was useful for you. A lot of AC powered motors, they rely on a capacitor to allow them to function, and when they don't function, it's quite often just the capacitor. So we'll leave it at that. Thank you very much, and catch you in the next one.